To think about how to count a pattern that is linear in nature, I want you to try to start to visualize it. So without counting one by one, how many helmets are there? How might we visualize this counting? Well, I noticed that 2 and 8, when I add that up quickly, 2 and 8 add together to be 10. So I can kind of visualize moving that column of 8 helmets over to add with the 2. And if I do the same thing with the 4 and the 6, I notice 4 and 6 also add together to be 10. So I can move over the 6 column and add that together to be 10. So I haven't counted each helmet individually, but just by quick patterning, I can see that I have 2 columns of helmets, and each of those columns have 10 helmets in it. So 10 helmets in the 2 groups. So each column representing this new group of helmets. Let's look at another picture. So without counting one by one, now what happens? How many helmets are there? Can we visualize in a very similar way? So once again, if I take the first section of helmets, 2, and add it to the last section of helmets, which is 10, I can group these together to see that I have a sum of 12. So I have 12 total helmets. And once again, by taking the next group, 4 and 8, that also has a sum of 12. But this time I have this middle group of 6 helmets that doesn't have any column to add to. But that's okay. We have 12 helmets, but we have 2.5 groups of helmets. I don't have another full group because of that's 6, but that's half of a group. So that would be 30 total helmets. Let's do this one more time. So without counting one by one, now we have lots of little helmets there. How many helmets are there? So can you visualize this? Once again, I take the first and last column. If I add those 2 columns up, 1 and 100, if I move over that 1, that little 1 first helmet there, if I move that over, you can see it right up here. I've moved it. Now I have a total of 101 helmets. Well, let's do that same thing with the next group. 2 and 99. So there's 2 helmets here, 99 helmets here. I could take this 2 and I can move it all the way over to this 99. 99 plus 2 is once again 101. Doing the same thing, 3 and 98. Here's my 3 helmets. Move it over to be here with the 98. That's once again 101. So it's really cool. I keep getting the same number if I take the first and last numbers in in the sequence, as long as it's linear. This will always work. So 4 and 97. There it is, right up there. My 4 helmets once again makes 101. So this cool pattern creates a nice 101 helmets in each of my groups. Well, how many groups would I have? If I went from 1 to 100, that would be 1 group, 2 groups, 3 groups, 4 groups. And if I imagine kind of working my way down to the center, that would be 50 groups. So there would be a total of 5,050 helmets. So to summarize this nice formula, if I have a linear sequence and I'm trying to add up all those terms, which makes it now a series to find the sum, I can just add the first value plus the last value, right? 1 and 100, because I'm always going to be adding that same amount. Well, how many times would I add that same amount? 50 times, or the number of terms divided by 2. So 100 here divided by 2. Let's go, this is what it would look like if I were to be using sigma notation. That's the sigma that we just solved for. Earlier today, we solved for this sigma. The pattern was 2n, the linear pattern. So that arithmetic model was 2n. And we solved where a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So from n equals 1 to 5. And we found that there were 12 helmets in 2.5 groups. So that's what we solved using sigma notation. But now we have this nice formula that we can use.